Welcome to Society of Civil Engineers today. We are going to understand value of pen in civil engineering field. The every stroke of a civil engineer's pen carries immense responsibility. It's not just ink on paper, but the blueprint for our built world, directly impacting public safety and structural integrity. Professionalism in construction engineering technology is paramount. It directly impacts the safety and quality of projects, ensuring the structures we rely on are sound and secure. From the initial design to final approval, a civil engineer's choices are intrinsically linked to public safety. These decisions form the bedrock of trust between engineers and society. Civil engineering is governed by strict professional and ethical codes. These guidelines ensure integrity and accountability in every design and construction decision, upholding public welfare. Engineers are tasked with designing structures that withstand immense forces. Their understanding of structural mechanics ensures resilience against natural disasters and daily wear. Ignoring engineering principles can lead to catastrophic failures. The burden of preventing such events rests heavily on the civil engineer's judgment and expertise in every project stage. Negligence or design flaws carry significant legal liabilities for civil engineers. Courtroom scenes illustrate the severe consequences faced when structural integrity is compromised. Engineers are accountable for their work, ensuring that every calculation and specification meets rigorous standards. This responsibility drives meticulous attention to detail. Civil engineers are the architects of modern infrastructure. Iconic bridges, towering skyscrapers, and vital dams stand as testaments to their expertise and structural responsibility. The field is continuously evolving. Studies like that exploring nanotechnology's integration into civil engineering aim to boost material durability and advance infrastructure sustainability. AI is increasingly playing a role in design and analysis, as discussed in a 2025 article in the American Political Science Review on structural responsibility. The professional demands continuous learning. Adapting to new technologies, regulations, and construction methods is essential for maintaining competence and ensuring public trust. Every project adheres to rigorous standards and protocols. This strict adherence minimizes risks and guarantees the long-term safety and functionality of all civil engineering endeavors. A deeper understanding of structures and their functioning is crucial. Normative discussions about structural responsibility often lack this comprehensive socio-theoretical view. Current views often reduce the relationship between structures and actions to one of constraint. They suggest structures primarily inhibit transformative action, an inadequate perspective. Actions gain social meaning through public interpretation, a crucial process described by the 2025 American Political Science Review article. Responsibility includes acting from one's structural position to disrupt mechanisms of structural maintenance, especially those perpetuating injustice. This proactive stance is pivotal. The lifespan of infrastructure can be decades, even centuries. Engineers design for longevity, anticipating future stresses and environmental changes in their initial plans. Climate change presents new challenges. Engineers must design infrastructure resilient to extreme weather events, from rising sea levels to increased seismic activity, safeguarding communities. Ultimately, civil engineering is about people, creating safe, functional, and aesthetically pleasing spaces that enhance human lives is the core motivation and burden. Engineers constantly balance economic feasibility, environmental needs, and public safety. This complex equilibrium demands astute judgment and ethical decision-making throughout the project lifecycle. Innovation, like integrating nanotechnology for durability, must always align with stringent safety protocols. Advancing technology means advancing safety measures, never compromising on either. Civil engineering standards are often global, reflecting shared principles of safety and quality. This adherence ensures universal reliability in diverse international projects. Every perfect bridge, every stable building, represents a silent battle won against gravity, decay, and the unforeseen. The engineer's triumph is in its peaceful existence. The responsibility extends beyond construction. Ongoing maintenance and periodic assessments are critical to ensuring the continued safety and functionality of infrastructure throughout its life. Risk assessment is an integral part of an engineer's role. Identifying potential hazards and implementing mitigation strategies prevents catastrophic failures and ensures safety. Behind every structure lies a labyrinth of complex calculations. Engineers must master structural analysis, hydraulics, geotechnical considerations, and material science for precision and safety. Every decision, from choosing a material to approving a design, is a critical moment. One error can have ripple effects, leading to severe consequences. Durability is a cornerstone of civil engineering. Structures must endure for generations, resisting wear, environmental factors, and the tests of time. Nanomaterials play a new role here. Civil engineers don't just build, they shape entire landscapes. Their projects become integral parts of the environment, both natural and urban, for centuries to come. While architects envision the aesthetics, civil engineers bring these visions to life, ensuring they are structurally sound and safe. It's a partnership of creativity and practicality. Roads, bridges, subways, and water systems are vital public infrastructure. Their flawless operation is a silent testament to the tireless efforts of civil engineers, foundational to society. Behind every reliable system, engineers design for safety. This principle is increasingly recognized in emerging fields like AI, where safety engineering ensures reliable, ethical systems. Engineers ensure systems work reliably, economically, and safely. This holistic approach means considering every factor, from material cost to human interaction, for optimal performance. Economic viability is a constant consideration. Projects must be cost-effective while never compromising on safety or quality, requiring ingenious solutions and resourcefulness from engineers. Innovation isn't just about advancement, it's about making things better and safer. New materials and techniques continually improve the resilience and longevity of our built world. Engineers often bear the burden of proof, demonstrating that their designs meet all safety and regulatory requirements. Documentation and rigorous testing are vital. Engineers frequently face ethical dilemmas, balancing cost pressures against optimal safety or expediting schedules against thoroughness. Each choice holds significant weight. Projects often involve extensive community engagement. Engineers must listen to concerns, integrate feedback, and communicate complex plans transparently, building trust with the public. Much of an engineer's work is invisible, embedded deep within structures. This unseen strength is what allows us to navigate our cities securely every day. Civil engineers must adapt to a constantly changing world. New materials, natural phenomena, and evolving societal needs. Their profession demands constant flexibility and foresight. The concept of structural injustice, as defined by Iris Marion Young, highlights inequities. Engineers have a role in ensuring equitable access to safe and sustainable infrastructure for all. Responsibility for structural injustice can be understood as political responsibility. This involves acting within one's structural position to dismantle mechanisms of systemic maintenance. The role of a civil engineer extends far beyond technical skills. It encompasses a deep understanding of societal impact, ethics, and the profound responsibility carried with every project. This vigilance isn't just during design or construction. It's a continuous daily commitment to ensuring our world remains safe, functional, and resilient for everyone. Civil engineers provide a silent service. Their work is often taken for granted until something goes wrong, highlighting the immense stakes involved in their everyday decisions. The field is never static. From traditional construction methods to the future of AI in design, civil engineers are at the forefront of continuous evolution, ensuring relevance and safety. Engineers are the silent heroes, working diligently behind the scenes. Their work ensures that the foundations of our society remain strong, safe, and ready for tomorrow's challenges. Beyond calculations, it's about the integrity of the design. A design rooted in ethical considerations and rigorous scientific principles is one that will stand the test of time. The burden of structural responsibility is a constant vigil. It is the unwavering commitment to excellence that ensures the safety and prosperity of generations. Every structure tells a story of care and dedication. Like and subscribe to join us in appreciating the silent guardians who build our world, ensuring its safety.